Hello my dear students. Now we are going to start with the chapter 2, metal forming process. This chapter is from manufacturing process of basics of mechanical engineering. So today we are going to learn the topic introduction of metal forming process. So what is metal forming process? It is a large set of manufacturing process in which the material is deformed plastically. This point is very important. Plastically to take the shape of the die geometry. We'll see what is die and what is plasticity. We have done already in the last unit of basics of mechanical engineering. What is plasticity, elasticity, and some mechanical properties. So what is plasticity? Plasticity is the ability of the material to deform permanently. Only deform, not the fracture. There should not be any fracture, but only there should be permanently deformation. So the tool used for such deformation are called as die, punch, etc. Depending on the type of the process. It depends upon the process, which type of process is going to be used. The die name will be changed. So what is plastic deformation? Stresses beyond yield strength of the workpiece material is required is to make plastic deformation. So what is yield strength? Yield strength is that strength of the material before which the force is applied on the material. It will not cause the permanent deformation or plastic deformation, but after yield strength the material will deform plastically. So the load applying on the material to make permanent deformation, we need to apply a force more than yield strength of the material. Categories. There are two types of metal forming process. First is the bulk metal forming process, and second is the sheet metal forming process. So in the bulk there are four categories, which are known as rolling, forging, extrusion, bar wire and bar drawing. And in the sheet metal process there are bending, deep or cup drawing, shearing process, and miscellaneous processes also. So just see the basics concepts of these metal forming processes. Classification of basic bulk forming processes. There are four types. What is bulk forming process? It is the severe deformation process resulting in the massive shape change. Shape change is important. The surface area to volume of the work is relatively small. The mostly done in hot working condition. We will see what is hot working and what is cold working processes. So rolling, what is rolling? Rolling this first process, which figure is showing that this is the rolling process. This is the same as a sugarcane juice making machine. Rolling, in this process the workpiece in the form of slab or plate is compressed into two rotating rolls in the thickness direction. So in the thickness direction the rolling force will be applied on this material, and input from here, and the output will be this. So the product will be in the right side of these rollers. So so that the thickness is reduced. The rotating rolls draw the slab into the gap and compresses it. The final product is in the form of sheet. So this slab will become sheet because the thickness is reduced. Forging, we can see here the deformation is plastically deformed, not elastically. If elastically deformed, the material will again regain its shape and size to this shape. So these forces will not affect any changes in this material. So the material must be deformed plastically. Forging. What is forging? Forging is the work in this. The workpiece is compressed into two dies. We can see there are two dies, this one and this one, containing the shape contours. Shaped contours means this shape contours the space. The contours will be the shape of the product, the inverted shape of the product. So that if we put the workpiece inside these dies, if we apply the forces in this direction, so we will have a product in the shape of cavity, or we can say the contour, the shape contours. The die shapes are imparted into the final product. The next one is the extrusion. In this, the workpiece is compressed or pushed into the die opening to take the shape of the die hole as its cross section. So we can see in this, the force is applying in this direction to compress this material and to taken out from this small space, so that it will form as a rod, or the we can say the diameter is reduced. This diameter is initially, but the finally the diameter is reduced due to the compression force on the workpiece, okay, by this ram. This is known as ram. The ram is applying the force on the workpiece, so that the material will come out from the small orifice, and this will become a product which will have a diameter smaller than the workpiece. So here the compression is required, and once again we can see there must be a plastic deformation, not elastic deformation. The last is wire or rod drawing. It is similar. We can say the diagram is almost same, but what are the differences? We can see the forces applying, the where is the forces is applying on the workpiece, where, here at the input, but here at the output. So we can say similar to the extrusion, except that the workpiece is pulled through the die opening to take the cross section. So this force is applying on the output part, and this force, this material will come out as a wire or bar, and this process is known as a wire or rod drawing. And this process is used to make a wire or rod very small diameter of product it should be. So this is all about the bulk forming process. Now we are going to see what is sheet forming processes. So here it is, there are three types. We will see bending, deep drawing, and shearing. The miscellaneous process will not cover, because it is not in the syllabus of the basics of mechanical engineering. So we just focus on the three topics, which is bending, deep drawing, and shearing. So what is sheet metal forming process? Sheet metal forming involves the forming and cutting operation performed on the metal sheet, strips, and coils. The surface area to volume ratio of the starting material is relatively high. The surface area to volume ratio of the starting material is relatively high. Tools include punch, die that are used to deform the sheet. So we can see here the plate is, so taking the first category, it is in this, the sheet metal is strand means plastically deformed by punch to give a bend shape, angle shape, usually in a straight axis. So applying this force on the punch, this is known as a punch, and this is known as a die. Die is providing the shape of the product. So we are going to bend this plate, just applying the force in the vertical direction in the shape of die. So here are also the plastic deformation will occur. The next is deep or cup drawing. In this operation, the forming of flat metal sheet into a hollow or concave shape like a cup is performed by stretching the metal in some region. A blank holder is used to clamp the blank on the die while the punch pushes into the sheet metal. The sheet is drawn into the die hole, taking the shape of the cavity. So we can see this is the blank holder, and these are the blank holder. What is blank? Blank means workpiece. This blank holder is used to hold this workpiece here and here, and applying the force from the vertical direction to get the shape of die. The shape of the die here is as a cup. So this sheet metal will convert it into a cup Okay, and this is also known as deep drawing or cup drawing. Last is shearing. This is nothing but a cutting of sheets by shearing action. We can see that this location of this plate is under a shearing force. What is shearing force? Shearing force is the force which is parallel to the cross section area. We can assume that this plate is like that. Not assume, the plate must be actually is in the form of rectangular shape. So if we apply the force here, this cross section area is parallel to the force. It is just as we can do in the case of, if we have an eraser rubber, and we are going to cut that rubber or eraser by a blade. So that kind of process is known as the shearing process, shearing or cutting process. So in the same process, we can assume that this is the blade and this is the rubber, and this rubber is going to be cut down along the cross section area. So this cross section area is parallel to this force. So that kind of process is known as shearing. Here also same figure after the shearing. Now the cold working and hot working process. What is cold working process? Generally done at room temperature or slightly above room temperature, above room temperature, and that temperature will be done. So now again we are going to see what is cold working process. Generally done at room temperature, or we can say below recrystallization temperature. So what is recrystallization temperature? What is recrystallization temperature? Recrystallization temperature is a particular temperature point below the melting point, below the melting point of a metal or material. This is because the grains we can assume here before the sixth unit is going to be started, the heat treatment process. So we just assume that the grains are the very small unit of a material, which is which can be shown, which can be seen at a microscopic level. So that grains at this temperature makes the metal behave in a plastic manner, allowing them to deform greatly for very less force application. Means at that temperature material will behave as a very soft material. So in that at that temperature we can apply a force to deform the material very easily. So if we apply that kind of forces on the material below this temperature, that process is known as cold working process. If we apply the forces on the material, if the material is kept at above the recrystallization temperature, then that process is known as hot working process. So I have given the example of, for the steel, the recrystallization temperature for the steel is typically between 400 and 400 and 700 degrees centigrade. What is why there is a range? Because there are different types of steel, so there must be different of melting point. So melting point is the measure of recrystallization temperature. So if the melting point is different, so recrystallization temperature will be also different. But we have to remember that that temperature must be lesser than the melting point of the material. So recrystallization temperature is always lesser than melting point of the material. So now we are going to see what are the advantage of compared to the hot working process. So I have explained what is hot working and cold working process. It depends only upon the recrystallization temperature of the material. First one is closure tolerance can be achieved in case of cold working process. Good surface finish also, because of strain hardening. Higher strength and hardness is seen in the part. Fourth is grain flow during deformation provides the opportunity for desirable directional properties. Since no heating of the work is involved, the furnace fuel electricity costs are minimized. Sixth is machining requirement are minimum, resulting in the possibility of near net shaped forming. The disadvantages are the higher forces and power are required. Why? Because the temperature is low in case of cold working process, so the material is not softer than if we softer to deform it, so the higher forces is required to deform that material. So second is strain hardening of the work metal limit the amount of the forming that can be done, means that we cannot achieve that much of deformation on the material in case of cold working process. Sometimes the cold forming annealing cold forming cycle should be followed. Okay, so you just remember these points and we will explain in the 6th minute topic the heat treatment process. What is this? This is telling. The fourth point is the workpiece is not ductile enough to cold work. Okay, so what is not ductile means if the temperature is rises, the material will convert into the ductile. So if at a room temperature or below the recrystallized temperature, material is very hard, so it is not a ductile material, so it is very tough to make apply the cold work. Next is the hot working process, involves the deformation above the recrystallized temperature that I have already explained, between the zero point 0.5 times of the melting point to the 0.75 of the melting point. Means we can see for the case of steel, the temperature must be above zero point 0.5 times of the melting point to the 0.75 to the of the melting point of the material. Advantages: the significant plastic deformation can be given to the sample. Second is the significant change in the workpiece shape. Deformation is first and second point are almost same. The lower forces are required. The third point is also connected with the first and second points. The fourth is the material with premature failure can be hot formed. Premature failure means if we want some failure inside the material, we can see the failure before applying the hot working process. The fifth point is absence of the strengthening due to hot work, work hardening. Absence of strengthening due to work hardening, because work hardening means when we apply the forces at a room temperature, the material will become so hard. After that, the force is if you apply the forces, it will not deform at the same rate. So if we increase the temperature of the material above the recrystallization temperature, there will be the absence of this strengthening, so the material will be easily deformed. What are the disadvantages of the hot working process? The shorter the tool life. Why the tool life is reduced? Because at a high temperature, the material will lose its some materialistic properties. Second is the poor surface finish. Poor surface finish because we apply the forces on the soft material, it will deform very drastically, so it will not give the good surface finish. Third is the lower dimensional accuracy. The second and third point is both the same, because surface finish is not as required, so in that case the dimension will be also be changed because of the high forces applied on the material, and the material deform very drastically, so we cannot get that much of accuracy. Sample surface oxidation. At high temperature, we know that at high temperature the chemical reaction are stimulated. So at high temperature the oxidation will occur on the surface, so the material will oxidized, and material there are the sides of the material the layer of oxides of the material will form at the surface. So these are the points for the cold working and hot working process. So in the next video lecture, we will discuss forging process. Till then, just stay tuned for the next lecture. Thank you.